Okay, so today we're talking about real zeros or polynomials. Our goal is to learn some algebraic methods to help us to find the real zeros of a polynomial. And once we have the real zeros of the polynomial, we want to factor the polynomial completely. So that's where we're heading. Okay, so first off, let's talk about the rational zeros theorem. I hinted at this in the previous section whenever we discussed it. Let f of x be equal to this polynomial of degree n, where an and a naught are not equal to 0, and each coefficient is an integer. If p over q in lowest terms is a rational zero of f, then p must be a factor of a naught, so it has to be a factor of your constant, and q must be a factor of an. So what this is saying is if you have a polynomial of degree n, then your rational zeros are of the form p over q. The p values come from the factors of your constant. Your q values come from the factors of your leading coefficient. Okay? Hello? Okay? All right, so let's list the possible rational zeros for the polynomial f of x equals negative 4 x cubed minus x squared plus x plus 2. What is your constant term here? 2. Very good. 2 is our constant term. What's your leading coefficient? Good. Negative 4 is the leading coefficient. What are the factors of 2? Plus or minus 1 and plus or minus 2. What are the factors of, minus there, of negative 4? Plus or minus 1, plus or minus 2, and plus or minus 4. Good. So, using the rational zeros theorem, we put our factors of a naught, which is 2, and our factors are plus or minus 1 or plus or minus 2. In our numerator, the factors of our leading coefficient, which is negative 4, go in our denominator. So, we would have 1 over 1, or plus or minus 1 over 1, plus or minus 2 over 1. So we would have plus or minus 1, plus or minus 2. Then we would have plus or minus 2 over 1, plus or minus 2 over 2. We already have that here, right? So then we would pick up plus or minus 2 over plus or minus 4. What's that going to be? Good, plus or minus 1/2. And what else do we need?
Plus or minus 1/4.
Good, very good. So these are your possible rational zeros. You have 8 possible rational zeros. So then what you would do if you had to find your actual zeros, you do a guess and check. You choose one, use the coefficients of your polynomial in synthetic division. See if you, whenever you synthetically divide, you see if you get a remainder of 0. If you get a remainder of 0, what does that mean? That means the number that you chose, the possible rational zero, is actually a 0. Very good. Okay? So, there you go. Now, finding the rational zeros of a polynomial. Finding the rational zeros of a polynomial, to do that, you list your possible zeros. You list all the possible rational zeros by using the rational zeros theorem from the previous page. Then you divide. So you use synthetic division to evaluate the polynomial at each of the candidates for the rational zeros that you found in step 1. And then when the remainder is 0, you make note of the quotient you found, okay? Because that means that the number you chose is actually part of your factor, okay? It's a 0. Then you repeat these 2 steps until you can no longer divide, okay? Until you found all of your factors. Okay? What questions do you have? Okay? The next rule that you need to know is Descartes' rule of signs. Okay? Descartes' rule of signs says let f be a polynomial written in standard form. Okay? So in standard form means you have your highest degree first and it's in descending order. Okay? The number of positive real zeros of f either equals the number of variations in sign of the non-zero coefficients of f of x, or it equals that number less an even integer. Okay? So, again, the number of positive real zeros of f either equals the number of variations in sign of the non-zero coefficients of f of x, or equals that number less an even integer. So, for example, we're going to go through an example on the next page, but let me just write something here so you can see it. So if you have negative 4x cubed, if we write down the polynomial from example 1, that was an x squared here, plus x plus 2. Notice that this is a negative. This sign here is a what?
Negative.
So there's no variation. But then it goes from negative to positive. That means we have one variation. Then here, does it change? No, so that means total we have one variation, okay? So the number, if we go back to this, it says the number of positive real zeros of f either equals the number of variations in sign of the non-zero coefficients of f of x. So here, it would be 1, or equals that number less an even integer. So we would subtract 2 from 1, but it doesn't really count because that gives us a negative, right? So we just have 1 or 0 here. Okay? 2, the number of negative real zeros of f either equals the number of variations in the sign of the non-zero coefficients of f of negative x. So what we would do here, you would substitute in negative x here for the polynomial to see what you get. You would have 4 times negative x cubed minus a negative x squared plus a negative x plus 2, which when simplified would give us 4, or that was a negative on the outside, right? So make sure we put that. So negative x cubed is negative x cubed times the negative gives us positive. So that's 4x cubed plus x squared minus x plus 2. How many variations here? 2?
1.
I'm asking.
2.
Where are they at? Talk. Where are they? Going from what to what and what to what?
Plus to minus, then minus to plus.
Going where though? Like from plus x squared to negative x,
Yes.
and then from
From negative x
to positive 2. So you have 2 variations. 2, or it says that number less an even integer. So what does that mean? 2 or? So up here it was 1 or 0 positive real zeros. Here is 2 or what? I explained in 1 what less an even integer meant. What does it mean here? So you would have 2 or 0 here. What's the degree of your polynomial? How many zeros do you have to have? 3. So that means you're going to have 1 positive and 2 negative zeros. You'll have 1 positive and 2 negative zeros. Okay? All right. So let's go through an example where we discuss or apply Descartes' rule of signs. We've already done one on the previous page, but just let's go over this one. So I want us to find the maximum number of real zeros and determine the number of positive and negative real zeros. What's the maximum number of zeros, real zeros, for this polynomial? 5. Very good, because that is the what? Good. So there are 5 maximum real zeros. Now, In order to determine the positive real zeros, what do we need to look at? Bless you. Read it on the previous page. You all are giving me blank looks, but you have to comprehend the information. What do you have to look at?
The number of variations.
The number of variations of?
Signs.
The number of variation of signs of
Function.
which function?
F of X.
F of x. Good. So we look at the function f of x, the number of variations. Count them. I'm going to move you count.
1, 2, 3, 4, 5.
So we have 5 or less than even integer. So tell me what are the other possibilities. 5, 3, or 1. Very good. Positive real zeros. Because we have five variations of f of x or less that of an even integer. Okay. So good. We found the maximum real zeros, the number. We found the possibilities for the positive real zeros. So now we found the possible positive real zeros. How do we find the possible negative real zeros?
Plug in, I think, negative x for x, right?
Yes. So we look at f of negative x. What's f of negative x going to be? You can give it to me the simplified version if you like. I'm asking.
Negative x to the fifth plus x to the fourth minus x to the third.
No.
Yes.
Nope. So you have, it's a good thing. So you make sure, the reason why you're thinking to just change the signs because you're not substituting it in for x. Make sure you're careful with your exponents. So you have negative x raised to the fifth minus a negative x raised to the fourth. Remember your algebra. A lot of mistakes are made because of the algebra. So minus negative x squared plus a negative x minus 1. That's equal to negative x to the fifth, as you said. What is negative x to the fourth? What's negative x to the fourth? Good, positive x to the fourth, but you're already subtracting it, so that remains. So minus x to the fourth. Then minus x cubed. Then what?
Minus x, minus 1.
Minus 1. This is what you get for f of negative x. So what can you say here?
0 negative, there are 0 negative real zeros.
Good. 0 negative real zeros because there are no variations. Because there are no variations. So what you get here, you can tell me how many zeros you have and what kind. So what can you conclude from all of this?
There's 5 positive zeros.
There's, right, you have 5 positive zeros for this polynomial. You will have 5 positive real zeros for f of x. Good. Okay, so now what we're going to do is we're going to use the rational zeros theorem we're gonna find all of the rational zeros of the polynomial, and we're gonna use Descartes' rule of signs to help us find out how many positive real zeros and negative zeros we have. And we're going to write this polynomial of degree 3 in factored form. Okay? So that's what we're going to do. So let's do it. So, the possible rational zeros are what? You tell me based on what we've talked about. What are the possible rational zeros? Just give me the possible ones. No?
2, or
So plus or minus 1, plus or minus 2.
anything over plus or minus 4.
So you have plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 1/2. Good. All right, so we have our possible rational zeros. And now, remember we took they came from taking the factors of your constant term, which is plus or minus 1, plus or minus 2, plus or minus 4, and dividing that by your factors of your leading coefficient, which is plus or minus 1 and plus or minus 2. Okay? Now we can look and use Descartes' rule of signs to figure out how many positive real zeros we'll have and how many negative real zeros we'll have. P of x, P of x has how many variations in sign? 1. Good. It has 1 variation in sign, which means P has 1 positive real zero. Okay? And then, since P of negative x, what's P of negative x going to be once simplified?
Negative 2x cubed plus 7x squared minus 4x minus 4.
Good. How many variations here?
2.
Good. It has 2 variations. It changes from negative to positive here. From positive to negative here. It stays the same here. So you pick up 1 variation, 2 variations. Okay? So, P will answer that. Since P of negative x has 2 variations in sign, P has 2 or what?
0.
Good. Negative real zeros. So, based on what we found, and we know the degree, that means we have how many negative real zeros? 2 negative real zeros, and how many positive? 1. Good. So, now what we're going to do, we're going to choose one of these and check to see if it works. Check to see if we get a remainder of 0. Let's just check 1. So 1, our coefficients of our polynomial is 2, 7, 4, and negative 4. We have 1, or we bring down 2. Multiply, you get what? Come on. We're using synthetic division. Tell me what we get.
2.
We got 2, we wrote it.
Next one's 5.
We're synthetic. Add, you get what?
9.
Continue.
Multiply.
Multiply, you get 9, and then 13 multiplied by 1, you get 13, and then you get -9.
And then you get what? 9. This doesn't have a remainder of 0, right? So 1 is not a factor. 1 is not a 0. Let's try 1/2. So we have 2, 7, 4, and -4 are our coefficients. Bring down 2, multiply, you get 2 times 1/2, you get. Add, multiply. No. Add, you get what? Multiply, you get.
Four.
Add, you get.
Zero.
So what does this mean? Good. This implies 1/2 is a 0 because we ended up with the remainder of 0. This means that P of x is equal to x minus 1/2, that's one factor, because 1/2 is a 0. Then we're left with a degree 2 polynomial with coefficients 2, 8, and 8. So it's 2x squared plus 8x plus 8. Then they all have a 2 in common, so we factor that 2 out. We'll have 2 times x minus 1/2 times x squared plus 4x plus 4. And then how can you factor x squared plus 4x plus 4? It's not x plus 4 times x plus 4.
X plus 2
X plus 2 quantity
squared.
squared. Good. Okay? So that's P of x in factored form. That's P of x in factored form, which is part of what we were supposed to find. And then we were supposed to find the zeros. Okay? Well, I didn't ask you to find the zeros of this. I asked you to find all the rational zeros. These are all the rational zeros. And then write the polynomial in factored form. That's this. But if I ask you what are the zeros of this polynomial, what are they? What would the zeros be of this polynomial? The zeros of, good, the zeros of P of x, and this is just extra information, are, you've already found 1/2. They are 1/2 and -2. What's the multiplicity of 1/2? 1. What's the multiplicity of -2? 2. Good. Remember, the degree of the factor tells you the multiplicity. Multiplicity of -2 is 2. The multiplicity, or the degree of x minus 1/2 is 1. So the multiplicity of 1/2 would be 1. This helps you when you're sketching a graph. Okay? All of this information that we're finding here is relevant. It's relevant because it helps you sketch the graph. What questions do you have? Talk. Why is it like pulling teeth to get you to talk? What questions do you have? Okay. So example 4. Example 4, we are going to find all the zeros of the polynomial and sketch the graph. Find all the zeros of the polynomial and sketch the graph. Okay, good. So we have the possible rational zeros. So remember, you get those by taking the factors of 15, dividing it by the factors of 3. So these are the possibilities. Now, let's talk about the variations. P of x has how many variations in sign? 2. Very good, because it changes from positive to negative here. That's one variation. Here it stays the same. Here it changes from negative to positive. That's another variation, and there's positive. So P of x has 2 variations in sign and hence, what can we say?
There are 2 or 0 positive real zeros.
You got it. 2 or 0 positive real zeros. All right, so now we need to look at what?
P of negative x.
Good. What's P of negative x?
3x to the 4th plus 5x cubed minus 16x squared minus 7x plus 15.
Good. Has how many variations?
2.
2. Good. Has 2 variations. So that means what? What does that mean?
Two negative real zeros.
2 or 0.
2 or 0. Good. So, since we have a degree 4 polynomial, what can we say?
There's 2 positive and 2 negative.
There will be 2 positive and 2 negative real zeros. That's what we can conclude from this. Okay? Now we have to choose a number and find a 0. That's what we have to do. Okay? I'm going to try 1. So our coefficients are what?
3, 5, negative.
It's not 3 and 5. It's 3 and negative 5. There you go. Good. And then synthetically divide. You have 3 times 1 is
3,
add, you get.
negative 2,
Multiply, you get.
negative 2,
Add, you get.
negative 18,
Multiply, you get.
negative 18,
Add, you get.
negative 11,
Multiply, you get.
negative 11,
Add, you get.
4.
Doesn't work. You didn't get a remainder 0. What about 3? Same coefficients. Multiply, you get.
9,
Continue. Add.
3, 4,
Nope.
Positive.
Positive 4. Multiply, you get.
12.
Add, you get.
negative 4,
Multiply, you get.
negative 12,
Add, you get.
negative 5,
And then multiply, you get.
negative 15,
And add, you get.
0.
0. It works. Good. So this means 3 is a 0. This means 3 is a 0. Good. So we found 1. Okay? This left us with coefficients of a what degree polynomial?
3rd degree.
A degree 3. Very good. So all I'm going to do right now is just write. So P of x so far is equal to the factor x minus 3 times the 3rd degree polynomial 3x cubed plus 4x squared. Continue.
Minus 4x minus 5.
Good. Now we need to continue our synthetic division until we at least get it to a degree what?
2.
2, right? Let's try negative 1. What are the coefficients we're using?
3, 4.
Not 3 and negative 5. We're now using the coefficients of that we were left with before.
I said
They
4.
get
I said 4. Sorry.
online.
I said
Good. I'm listening to all of you.
Yeah, sorry.
Sorry, there was a response online that said 3, negative 5, and then we're going back here, yes.
How did you know that it was a
Finish telling me the coefficients. There are 3,
4?
4. Good. Good, all of you, in class and online. I like it when everybody's talking, so that's good. Okay? Now, bring down the 3. Multiply, you get.
Negative 3,
Add, you get.
1,
multiply, you get,
-1,
add, you get,
-5,
multiply,
-5,
nope,
5,
5, add, you get.
0.
So what does this mean?
-1 is a 0.
Good, this implies -1 is a 0. So now, what degree polynomial, the coefficients are we left with? 2. Very good. We have the coefficients of a degree 2 polynomial here, and we can say that P of x is now x minus 3 times what factor?
X plus 1.
Good, x plus 1, because you're subtracting a -1. Good. Times what?
3x squared plus x minus 5.
Plus x minus 5. Good. That quadratic doesn't factor as easily. So what should we use? Good. We'll use the quadratic formula. So we're going to use the quadratic formula to find the zeros from that quadratic. Okay? So remember the quadratic, we need to know A, B, and C. A is going to be what? 3. What's B? 1. And what's C? -5. So we're going to have x is equal to -b plus or minus the square root of b squared, so 1 squared, minus 4ac all over 2a. So that gives us -1 plus or minus the square root of 1 plus 4 times 5 is 20, 20 times 3 is 60, a negative, you're subtracting a negative, so this means plus 60 all over 6. So that gives us -1 plus or minus the square root of 61 divided by 6. So those are our other two zeros, okay? So we can say the zeros are 3, or we can put them in order. We can say -1, 3, and we'll have -1 plus or minus the square root of 61 all over 6. What's the multiplicity of each zero? 1. Each zero has multiplicity. All the zeros are there and they all have multiplicity 1. And we're only talking about the multiplicity because what's the second part of this question or this problem? Graph it, right? So if the zeros have multiplicity 1, what's going to happen at those zeros? I can't hear you. They cross. Good. They're going to cross, right? The degree of this polynomial is what? 4. What's the end behavior? Use your arms. Good. It looks like it's going up like this. Very good. Looks like this. Okay? So we can go ahead and plot those zeros. You can use your calculators to get an approximation of the ones that came from the quadratic formula. So these zeros will be approximately these ones here. Will be approximately -1.46 and 1.135. Okay, so whenever we plot all of these zeros, we have -1, then we have -1.46, then we have 1.135, and then we have what? What's that last zero? 3. Good. What's our y-intercept? What's our y-intercept?
The 15.
Yes, you substitute 0 in, you find p of 0, you get 15. Good. So you have your y-intercept here at 15. Remember, you just showed me your end behavior was here, so it's going to cross, it's going to go back up, cross, and then go back up. That's your sketch of your graph. That's a sketch of your graph. What questions do you have? Okay. So you can, there's a question online. So now let's talk about the boundedness theorem. The boundedness theorem says, let f of x be a polynomial function of degree n greater than or equal to 1 with real coefficients and with a positive leading coefficient. That's important. If f of x is divided synthetically by x minus c, and a, if c is greater than 0, and all numbers in the bottom row of the synthetic division are not negative, so in other words, if they're all positive, then that means that f of x has no zero greater than c. So in other words, c will be an upper bound here. So if all of the numbers in the bottom row of your synthetic division are positive, that means that number that you use, that c, will be an upper bound. Okay? Now, if c is less than 0, and all the numbers in the bottom row of the synthetic division alternate in sign, with 0 considered positive or negative as you need it, then f of x has no zeros less than c. So in other words, c is a lower bound. So c is a lower bound. You get an upper bound from this one, and you get a lower bound here. Okay? So now let's go through an example. We're going to show that for f of x equals x to the 4th plus 5x squared plus 3x minus 7, there is no real 0 greater than 1. Then we're going to show that there is no real 0 less than negative 2. Here, what do you expect to see in the synthetic division for part A in the bottom row? For part A in the bottom row, what do you expect to see happening?
They're all positive.
They're all positive. Good. So let's verify that. So our C is 1. What are your coefficients?
1, 5, 3, -7.
No, you said 1, 5, 3, and -7. What is missing?
0.
0. Good. There is no term of degree 3, so you have to put a 0. So 1, 0, 5, 3, and -7. So you bring down your 1, multiply, you get 1, add, you get
1.
multiply,
1,
add,
6,
multiply,
6,
add,
9,
multiply.
9,
Whoa. Good. And you add
2.
2. The numbers in the bottom row are all what?
Positive.
Positive. So that means by part A of our boundedness theorem, f of x has no real zeros greater than 1. So in other words, 1 is an upper bound. Part B, what do you expect to see in the bottom row?
They all alternate sign.
Good, that they're alternating in sign. So we use -2. Would you like a minute? Okay, take a your coefficients.
1, 0, 5, 8, 6, 7,
Talk loud, please. 1, 0,
5, 3, 7,
good. And then you bring down your 1, multiply, you get, add, you get, multiply, add, multiply, negative 18, add,
Negative 15.
multiply, add. Good. They all do what?
Alternate sign.
They alternate in sign here. So that means by part B of the boundedness theorem, f of x has no real zeros less than -2. So in other words, -2 is a lower bound. -2 is a lower bound. Okay? All right? So that concludes the real zeros of polynomial section for section 3.4.